as I said, we're finished with our formulas and our identities, and so far there's just a couple of last ideas that we're going to cover in our trig work before we move on to vectors after our next exam. And that's the law of sines, which we'll cover in this lesson, and then the last lesson in trigonometry will be the law of cosines. It's the one other place that we move back to degree measure and move away from radian measure. And we're going to work with our calculators for these next couple of lessons, and we'll need, again, to make sure that we are in degree mode when we do this. The reason I'm covering law of sines and cosines, it is obviously trig concept, but also it is something that you might see or you will see occasionally on the ACT. So if we cover the law of sines and cosines, then you might feel more comfortable when you see it on the ACT. Again, it's something we're going to do in degree measure, and they're fairly straightforward. So the law of sines says this: if we have an oblique triangle and we have triangle ABC, we're going to call the side opposite the angle the little letter. So if I have angle A, then this side I'm going to call side little letter A. If I have angle B, the side opposite that angle I'm going to call little letter B. Angle C, the opposite side would be C using the little letter. And if that's the case, then there is a relationship amongst the sines of all three of these angle measures and their corresponding sides. And here's the relationship. It's called the law of sines. It says that the side A, which is the side opposite of angle A, divided by the sine of angle A, will always be equal to the side B divided by the sine of its angle measure, the angle opposite that side. And that's true all the way around the oblique triangle. So A over sine of A equals B over sine of B equals C over sine of C, where little a, little b, and little c are the side length measures in the triangle. And that helps us use some trigonometry, use the sine value on a triangle that's not a right triangle. It's the only non-right triangle work that we can do in trigonometry. That's the law of sines, and then we'll see the law of cosines in the next lesson. So make sure that the law of sines is written in your notes. Make sure that you make note that little a, little b, and little c are side lengths that are opposite this angle measure. All right? So the capital letters are angle measures, the little letters are side lengths. So we use this fact that they are equal to set up ratios. We usually just use two of these ideas and set up a ratio. If we know 3 out of the 4 of these values, then we can solve for the fourth value that might be the unknown. And that's how we use the law of sines. So let's work an example. Again, I want to say this is going to be in degree measure. So if I'm given the angle measures of two angles in my triangle and one side length, and then I'm asked to find something that's missing, then I'm going to use those values and set up a ratio using the law of sines to solve for the unknown. Here the unknown is an angle measure. So if I know the measure of angle A and the measure of angle C, I can use that triangle sum theorem from geometry that says in any triangle, right or not, the sum of all three angles will always be 180 degrees. So I'm going to take 180 and subtract 102.4 and 16.7, and that will give me a measure for angle B of 60.9 degrees. So now I know all three angle measures. If I want to continue to find the measure of side B, here's where I'm going to use the law of sines. And if I want the measure of side B, given the measure of side A, that forces me to use this, the sine of angle measure A, because little a over the sine of angle A equals little b over the sine of angle B. So this is what we're working toward here. We're going to use this ratio to actually find the side length of B to this triangle. And so we're going to put this into our calculator. We're going to get a value of it. And if we want to be accurate to 1 decimal place, I would warn you again, you want to give this value greater to 1 decimal place. So that once you do all of this math, you want to give this value greater than 1 decimal place as well. So when you do all the math and you actually solve for B and you round it to 1 decimal place, you're absolutely certain of the accuracy of that one decimal place. So we're going to solve this for b. B equals, if we cross multiply and then solve for b, 21.6 times the sine of 60.9 divided by the sine of 102.4. If we do all that work using our calculator, and I haven't shown all that on here, you can pause the video and find those values and substitute them in, but I didn't want to waste time on the video doing that when I know you're perfectly capable of doing it. And when you round that accurately to the first decimal place, B becomes 19.3. So now, if they want us to find side C, we're going to use the ratio. We could use either ratio. We could use side A over the sine of A, or we could use side B over the sine of B. Here, they've used little a over the sine of big A, but it could be anything, because going back up to the law of sines, we can use any part of this ratio. We could set these two equal to each other or these two equal to each other and solve for the unknown. So let's go back to where we were here. So again, we're going to solve this for C. We're going to put those values into our calculator. You actually already have those values from our last work, and we find that the length of side C is 6.4 if we round it accurately to one decimal place. So there we are. We're done. That's the law of sines. Pretty straightforward. You just need to know that those ratios equal each other, and you use that information with the given information that they give you, and then solve for the unknown that they're asking for. So we're done. Come to class next time and we'll work on the law of sines. Make sure you bring your calculator.